VR authoring. My name is Dan Miller. I'm an evangelist at Unity. My specialty is virtual and augmented reality, and that's my Twitter handle. And so before we get started, I just want to do a quick poll. How many people in the audience are artists, and how many people, how many people in the audience are artists? A couple people. How many people in the audience are developers? Cool. All right, so this talk's a little more technical, or I can go over some of those things, so that's good. So the objectives here are going to be an overview of kind of the current VR platforms, what the ecosystem looks like right now, and some of the specifics when developing for those. Next, I'm going to talk about cross-platform techniques, looking at the future and things to consider today. And then I'm going to go over some tools and packages that are available in Unity, within Unity, and then developed by third parties. And then lastly, I'm just going to end with some kind of high-level ideas or things that I think are important when developing for VR. The current VR ecosystem right now, so we have the Daydream headset, the Gear VR, and the Cardboard. And so on this side of the ecosystem, these are VR devices that are all powered by mobile phones. So this means that you're inserting your phone that is at a certain spec, and it allows the VR headsets to take advantage of things like the gyroscope and accelerometer in the phone to get rotational data, but it doesn't have any external sensors to get positional data. So on the other side, we have the Oculus Rift, the HTC Vive, and the PlayStation VR. And so these are all high-end headsets that allow you to plug in your headsets into either a high-end PC or a gaming console. And what these have is all have external sensors that allow the headset to track your position. So as well as your rotation, like you get with the mobile, but you can also kind of walk around and get positional data inside these headsets. And so for high-end VR, one of the things that you really want to do is maintain 90 frames per second. With the ability to move around in space as well as rotate your head as quickly as you normally can, it's important to maintain a high frame per second. If you drop frames or if you're at lower frames per second, then the user in the headset is very likely to get nauseous or disoriented because it becomes unnatural what you're looking at as you move around in the experience. One of the nice things with the high end is that you can take advantage of a lot of the platform-specific features. So things like Oculus Home that allow you to make customized avatars. You can actually build those into your applications. And Steam has a variety of features, things like trading cards that can incentivize some of your players and achievements. And the nice thing about high-end VR is that you can target multiple controller types. So these two headsets, as well as the PlayStation VR, have motion-tracked controllers, but you can also target things like a gamepad, you could do keyboard and mouse, you could do joystick, and so on these high-end platforms, you kind of have the freedom to target which controller type is applicable to your experience. And the next thing is room scale, and so that's kind of what I talked about, where you can move around in the room. And this is because there's external sensors that are tracking your position. And so both the Oculus and the Vive support this room scale idea where basically you can lay out your certain size of your room and then build experiences around that. And so this is just a picture of like the Oculus avatar that you yourself would customize. And this is the one inside Unity that you could then use within your application. So for mobile VR, you must use the platform SDK. And so the Oculus has its own SDK for the Gear, and then Google for the Daydream has the Google VR SDK. For the mobile, you have to try to maintain 60 frames per second. So basically mobile phones are less performant than high-end PCs or desktop, and so they've set the bar a little bit lower. And what helps with this is that the field of view and things like that are a little bit smaller, and so you're not doing as quick of movements, as well as you're only tracking rotational data when you're in the mobile headset. One of the things with mobile VR is that you have to run on all the supported devices. And so right now, it's a smaller ecosystem, so these Android devices right here are all the devices that are compatible with the Gear VR. And so if, as we all know, there's literally thousands of Android devices out there. So one of the nice things for now is that these are kind of a limited ecosystem of devices. But that's kind of a requirement when publishing for the mobile stores here. Another important thing, and this is where things can get pretty difficult with mobile VR, is that you basically have to have your application be running for 45 minutes or longer without triggering the device's overheat warning. So mobile phones do a lot of different things. You know, we can send messages, we can talk on the phone, we can play applications, and so in our current iteration, we're really pushing these devices for the VR. And so for VR rendering, you're basically rendering 2 versions of the same scene at 60 frames a second, 1 for each eye. And so what this means is that there's a lot of stuff going on the phone. It's very taxing on it. And so you need to take into account a couple things in order to optimize it, in order to have it run for this 45 minutes. If it's unoptimized, or if you haven't taken account into this, the phone will basically overheat and then just shut off automatically, and that's one of the certification steps for developing on mobile. And the last thing is that the controller needs to meet all the input and interaction requirements. So the Gear VR now has a controller, which you can see down there in the corner, and the Daydream has a controller as well. And so the platform holders here have laid out specific requirements for these controllers. So both of the controllers have small buttons on the side. These are used to adjust the volume up and down, and so that's like a requirement that you can't override that controller functionality. And again, most of these requirements that I'm talking about are when you're publishing for the specific stores. So for the Google Play Store for Daydream and for the Gear VR store for Android. And one thing I want to make a note for trying to hit this 45 minutes or for keeping your heat low, there's a couple different things you can do. One of them inside the Unity player settings, there's a setting called experimental graphics. And what this does is it allows the rendering and the processes of the application to be split among the mobile cores. So without that checkbox active, everything's just going to be running on a single core. And with it checked off, you can basically migrate between and allow your application to take advantage of both of the cores. And reducing CPU load is something that's really important when reducing the amount of heat and thermal consumption of your application. The next thing I just want to note here is that there's something else called VR render scale. And this is by default set to 1, or it's 1.0. And a kind of small optimization or trick you can do, and this is going to be dependent on what your application is and the visual fidelity that you're looking, but you can actually reduce this render scale to something like 0.7. So instead of rendering the entire field of view that you would normally get, you're rendering about 70% of it. And this will still fill up the field of view inside your headset, but what it'll do is it'll allow your application to have a little bit less fill rate. And it's kind of a small optimization, but we definitely recommend trying it out to get those extra minutes or things like that. All right, so now I want to talk a little bit about the future VR ecosystem. So I went over and I said kind of what all these are and what's out right now. And after this slide, I'm going to talk about a little bit of things you can do to prepare yourself or prepare the applications you're building now for the future. So, right now we know that these high-end headsets have motion-tracked controllers. We know, so this right here is a headset that LG is developing. And so they're actually developing it in conjunction with the Steam VR tracking platform. And so if you're building an application right now, the last thing you want is for your application to basically be dead or be impossible to experience in 1 year, 2 years, 5 years. Maybe someone has a headset like this. Maybe someone has a headset that looks like this. Maybe not that one. Maybe someone has a headset that looks like this. And so there's this idea that with digital creation or things that live strictly in the digital space, that if we're not careful or if we're not kind of thinking ahead or have a lot of forethought, that these experiences could just be completely dead. The best application right now could could no longer exist or no longer be experienced with these new iterations of headsets. You know, we don't know exactly what's going to be in the future, but we can start thinking about it and planning our application and developing for things like that. And also, you know, maybe everyone's just making their own VR headsets in the future. Don't really know. All right, so this goes along with the idea of cross-platform VR. And so right now, we have native VR support inside Unity, and that's in the Unity Engine VR namespace. And so what you can do is you can take advantage of VR nodes and VR node states. And so right now, VR nodes is just an enumerator, and we've identified some specifics that we think are applicable to this generation. But one thing that we're really paying attention to and trying to think about is what's going to be applicable to the future generation. So right now in the VR node state enumerator, we have things like left hand, or left controller, right controller. We have things like head-mounted display. We have things like hardware tracker. And so the idea is that if you build an application today and you are taking advantage of these VR node states, I'm not, you know, as at an application level, I'm not worried that it's the Vive motion controller or the Oculus motion controller. I'm just looking for the left controller and the right controller. And then so the VR node state is basically what you pull inside the update function to get things like position, rotation, acceleration, and basically different data from the node itself. And so then this comes into the idea of controller abstraction. So if I'm using the VR node state to maybe move around my controller, that'll automatically just work on any platform that has an idea of a left controller or a right controller. And the idea as well is that in the future, you know, maybe we have a left glove and a right glove, but these enumerators will hopefully be backwards compatible in that even if you have a new type of controller and maybe you're holding it in your left hand, or maybe in the future we don't even use our hands, but you know, something on the left side of our body can still be represented here. And so with this controller abstraction, what we can do is separate the motion of the controller. So, you know, positionally or you know, what I want it to look like doesn't necessarily relate exactly to the input. Now, if you are just rendering the VR controller specifically, that's a little bit different. But say if I'm just rendering a hand, I want the hand to look the same on the PlayStation as it does on the Vive. And then what you do is you allow the motion and position of the controller to be controlled through these VR node states. And then the input is in a separate class that's separate from the functionality of the controller. So in that input is where I'm testing, you know, what platform am I on? Okay, I'm on the Vive, look for the input for main trigger down. Okay, I'm on the Oculus, you know, look for touchpad down or something like that. And so thinking about these things now and creating this separation can be some good steps to A, allow you to just release on all platforms. Obviously there's a little bit of more work involved, but and B, just hopefully future-proof and think about how your game and application can be experienced in the future. And so the next thing is targeting multiple SDKs. So right now inside the Unity player settings, we have a virtual reality supported checkbox. And when you check that, we now have the option to add certain VR SDKs. And so right now for HighEnd, we have the Oculus SDK, the OpenVR SDK. And what this does is it actually has a fall through. So if you built an application and let's just say for mobile, and you have the Daydream SDK as well as the Oculus SDK, and then you launch your application on a Gear VR device, because you're still building an APK for both of them to run on Android, it'll notice that the Daydream SDK or the Google SDK won't get initialized, and then it'll actually fall through down to the Oculus SDK. So you can build applications with multiple SDKs in mind. And now I kind of want to talk about this, this idea of OpenVR. And so you'll notice I say target OpenVR first. That's just kind of my personal opinion with creating things for the future or just really thinking about your applications down the road. And so basically OpenVR is an SDK that falls under the OpenXR, And so this is a group now within the Kronos group, and what they do is they set standards for basically interfaces and APIs, things like OpenGL, and now they're working in conjunction with multiple different companies, including Unity, Valve, and some of the headset manufacturers. And what they're doing is they're basically creating this, this layer between the application and between the device. So instead of worrying about your specific app that's built for one specific platform that's using one specific SDK, what you can do is you can actually build an application. It will interface with this OpenVR or OpenXR application interface, and then the application interface will handle what platform it's on, and that's to take advantage of things like the Steam VR and maybe the friends list and some of the Steam functions. And then it'll go one level lower to the device layer, and what this allows you to do is target multiple devices. And so the OpenXR device layer is what's handling that kind of multi-platform. And so to see this in action right now, if you build an application in Unity, use the OpenVR SDK, and let's just say I'm building for HighEnd, and so I produce a EXE, and if I plug an Oculus Rift into my PC right now and launch that application, the Steam VR will actually, because let's say that's the software I have installed here on my computer, Steam VR will actually recognize that. It will, right off the bat, give me things like rendering my controllers to be the actual Oculus controllers. It'll still give me the room scale and the headset setup. And then if I unplug the Oculus and plug in a Vive, right now, run the same application, I'll get the same results, but with the Vive. So instead of rendering the Oculus controllers, it will be able to tell. It says, hey, you have a Vive plugged in. I see you have your motion controllers here. And so it'll render those motion controllers to be the controllers that you're expecting. So this is already possible right now by targeting the OpenVR SDK, building your application in Unity, and then letting OpenXR handle some of that cross-platform ability. And so you'll notice as well, if you launch an application on Steam, you can actually specify which headsets you support. And so depending on the complexity of your application, right off the bat, you could support the Oculus, the Vive. There's a headset called OSVR, which is open source VR, as well as other things like that, kind of right off the bat. And so to me, this is really an important thing to keep in mind, especially when building for the future, because OpenXR also is very conscious of this idea that VR is changing very rapidly. Lots of new headsets are coming out, lots of new controllers are coming out, and they want to be there to kind of interface between your application and hopefully allow some future proofing of what you have now to be experienced with these future iterations of hardware. All right, so now I'm just going to talk about some tools and packages. And so this is helpful for getting started with VR inside Unity. So the first one is Steam VR. So we have a close partnership with Valve, and they are using Unity to create a handful of their VR games. And so they released the Steam VR basically SDK or package that's on the asset store. So this is free to download. It has an interaction system built in that they used for the lab. It has haptics examples, UI, UX examples, and a built-in teleport. And so here's a little screenshot of it. But right now, you can actually download this on Unity. It's all free and openly available. And it includes things like the bow and arrow, if you've ever played the lab game, The Longbow. And so you can see what they've done and how they've ramped up their production using Unity and using the OpenVR SDK. And so some of these UI, UX examples are really interesting in that it's things like levers or UI buttons and stuff like that that are really helpful in kind of basic VR interactions, as well as a teleport system. And then the nice thing too is that this is all just open source. So you can extend it, you can use it in your own application, and they've also taken some steps that I've talked about previous to allow things to just be cross-platform. If you launch this on a Vive, it'll work almost identical to if you launched it on an Oculus Rift. The next one I just want to mention is VRTK. And so this is an open source package that has things like locomotion, cross-platform, 2D and 3D element interactions. And so here's just a small little GIF of someone showing off some of the interactions. And so if someone comes to me today and says, you know, I want to get started in VR right now, I've never programmed before, or I've programmed a little bit, but I don't know some of the complexities of it, I often point them to this VR, it's called VR Toolkit, but it basically has numerous examples, like over 50 scenes of different kind of specific VR interactions. This is things from, you know, maybe a dash teleport where you move quickly through the space, or you can see here some like interface with buttons and stuff like that. And so this is, again, really extensible, and there's a nice community behind this that you can take advantage of. All right, so the next thing I want to touch on is some tools and packages for the platform. So Google, which is using Unity very heavily for their Daydream platform, they have a new package called Google Daydream Elements. And so this is things like locomotion, controller menus, material pack. And so you can see here in these 6 little icons here is what they've done is they've taken some interactions that they've seen inside VR. And I know specifically a couple of them, they've seen them in other applications, and they were kind of annoyed with the way people implemented them, or they weren't happy with kind of the quality. And so they put together this package here so that anyone could take advantage of these. And this material pack here with the Daydream renderer is basically a set of materials inside Unity that has been optimized specifically for the Daydream and mobile platform. And so a cool thing too is that while these were built with Daydream in mind, that all of these again are open source, and you could potentially use these for other applications not on the mobile platform. This is kind of an interesting one here. If you guys have ever tried out Google Earth VR, basically they have this movement system, and what it does is it actually focuses the center of your screen, or what you're looking at, to be where you're going. And then outside of that, it kind of grays out the rest of the world, and it gives you a flat horizon line as well as some grid patterns. And what this does is this greatly reduces motion sickness and nausea, because you have this straight horizon that you can see in the distance. You have kind of a grid around you. And so even though you're traveling forward in space in the application, but you're standing still in real life, some of these techniques here will help reduce nausea. And again, this is kind of just freely included in this Daydream Elements package. Next one I just want to briefly mention is the Steam Audio Pack. Basically what they've done is, audio in general is extremely important inside virtual reality. And so they've built a package on top of Unity's audio system to take advantage of things like spatialized audio. And so this allows you to have an audio source that is correctly, bouncing sound waves off depending on the occlusion and position of it in space. So, if my phone is beeping and it's doing an alarm, and if I put it inside here, it's going to sound a lot different than if it's right out here. And so they've built a system around that, in that you can position objects, you can bake certain kind of light setup or sound setups, and taking advantage of that in Unity. And again, open source and freely available. All right, so now I'm going to move on to ideas. And so these are just kind of some general things that I think are important, or everyone should keep in mind when developing for VR. So the first one's think about the future. I've kind of touched on this previously. We're in a state now where things are still much in its infancy. We've decided on a few specific things where we want motion tracked controllers, we want a headset, we want to be able to walk around, but we don't really know what the future is going to be. And so taking some steps now and having some forethought to think about what different things might come, I think is a really important idea. Don't let anyone prevent you from trying out an idea. So I've been working in VR for a couple years now, and there's been numerous people who have had maybe interesting ideas, and you tell someone about it and they say, that sounds good, but everyone's going to throw up, or everyone's going to get sick from that because your locomotion method won't work, or it's too wild. And so I always encourage people to really try out your idea. And there's a game out there where you're basically climbing around, but you're actually standing still the whole time. You're just using your arms to move. And he's taken advantage of some of those like locomotion things that Google's doing, where they kind of blur things out, or they show a horizon or a box around you, as well as the physicality of it actually makes it kind of all right. And you don't necessarily get as sick as you might think you do, or you might think you might before even trying out the idea. So always try things out. Test, play test, repeat. So it's really easy to build a scene inside Unity, think it's good or think you have a really good idea, but when you actually put on the headset, when you're actually experiencing the application, things are a lot different. And that's everything from the distance of how far things are away, how natural things feel. And so this really iterative process of trying things out, testing what you built is really important. Play, play, play. So I think this is super important. VR, while the amount of applications have grown a lot recently, it's still much less than, say, are on a mobile phone or are on the console market or anything like that. And so personally, I think it's really important for anyone developing VR to really try out a lot of VR applications. And so there's places like Steam, the Oculus Store, and there's numerous applications that have kind of floated to the top because of their quality, as well as just applications literally getting released every day. And so what I think is important is by just testing out these applications, seeing what they're doing right, maybe borrowing some elements from them, borrowing some elements from another application. And I think it's just really important to make sure that you're staying on top of things and seeing what other people are doing. And so think about UI and UX differently and often. So in traditional games and even in the start of a lot of VR applications, there was this idea that you kind of have a laser pointer. The Steam VR works similar to that, where there's just basically a kind of plane there, a flat plane with buttons, and you're pointing a laser at it. And that's kind of the traditional way that games have done UI forever or in the past. And then there's also this idea with UI where, if you have a health bar and you're making a game, you just kind of stick it in the upper left-hand corner. Well, in VR, anything really stuck to your face can feel a little bit disorienting, especially if it's not in your general field of view. It's, we can all move our eyes around and we can look at, I can look at this light up here without moving my head too much. But when you start to do that often, your eyes get really strained. And so there's interesting things to think about with UI and UX. And to me, the physical element of virtual reality really allows us to kind of break out of what we've done traditionally and think about new ways to do things. And maybe that's, you pull something out of your backpack, or you spawn a backpack in front of you and you're kind of grabbing elements out of the air. And so some of those experiences can, while equipping your sword isn't supposed to be the most fun thing you've ever done in a game, in VR you can kind of think about that differently and make it at least an enjoyable experience to kind of grab that. And so with that, I'm actually all done. So if you guys have any questions, yeah, let me know. Thanks.